everyone, my name is Qing. Today I will give a presentation about lithium-sulfur battery catalyst. This paper was published on Advanced Materials. I will introduce from the following 5 fields. First part is about the fundamental challenges of the lithium-sulfur battery cathode. As we know, battery has been a hot topic due to a wide applications in our life. For example, mobile phone, cars, but most battery is the lithium-ion battery. Lithium-sulfur battery is a promising substitute to the current lithium-ion battery. From this graph, we can know as theoretically, lithium-sulfur battery can give a high specific energy, like around 2600. It is more than 7 times than lithium-ion battery. Commercial lithium-ion battery can give a air capacity around 4. If lithium-sulfur battery want to get the equal value, the sulfur loading amount need around 6 to 10. However, nowadays, lithium-sulfur battery has a low sulfur utilization efficiency, less than 80%, and low sulfur loading, around 2 to 4. Electrolyte to sulfur ratio is more than 10. The self-discharge is serious. All the problem is originated from cathode problems. Sulfur and lithium sulfide has a low conductivity and has a big difference between the sulfur and the lithium sulfur density. So there is a serious value expansion. Also, the key factor is a shuttle effect. It will result in activity material loss and low charging efficiency, and impedance will be increased, and access of lithium ion will be retarded. So what's the shuttle effect? Actually, shuttle effect is because of dissolution of lithium polysulfides and slow kinetics reaction of soluble lithium polysulfides to insoluble lithium sulfide. But this part can contribute 75% capacity. So it's very important. In the reverse reaction, a large activation energy from lithium sulfide to lithium polysulfide. How to solve the shuttle effect? So first we should strengthen interaction between lithium polysulfide and the cathode material. Second, we should increase the lithium sulfide nucleation and transformation. And the last one is the speed up reduce kinetics from lithium polysulfide to lithium sulfide. So catalyst development satisfies all the requirements. So what kind of catalyst can be applied into lithium sulfur battery? In another word, it means what factor can determine catalyst. So firstly, we should know the reactant property. The lithium polysulfide belongs to Lewis base and polar molecular, and it has a bond energy between electrolyte and lithium polysulfide is around 0.87 to 0.98. So catalyst should have a high bond energy with solidified, like polar to polar ring interaction or Lewis acid to base interaction, and should have a high activity size, and also should conductivity high and low press and easy synthesize. Electrolyte cathodes can be divided into mantle-based cathodes such as mantle oxide, sulfide, nitride, and mantle-free cathodes like phosphorins and Lewis base and heterostructure. All the cathodes should efficiently trap lithium polysulfide and enhance the reduced reaction kinetics. The following is some typical examples. First is mantle catalyst, PT. The PT particle is disappeared on graphene. The catalytic performance. From this figure, we can see there is a positive shift in reduction peak and a negative shift in oxidation peak. Also, there is the two distinguishable oxide peaks. They all show this catalyst can increase the reversibility of the reaction, and the specific capacity of the PT graphene increase 40% than just graphene. Exchange current density of the PT and graphene is larger than printing. And under PT catalysis, specific capacity is around 1,100 mAh per gram, and the coolant efficiency around 99.3%. This is mantle oxide. MnO2 nanosheet is a very typical catalyst in lithium sulfide battery. Under MnO2 catalysis, we can get a high specific capacity 1,120, and after 200 cycles, it still can keep 1,030. For mantle oxide, there is a Goldilocks principle, because the lithium-sulfur battery work potential range is from 1.6 to 2.9. If mantle oxide with a lower potential, it will interact with lithium polysulfide with polar-to-polar interactions. If mantle oxide with higher reductive potentials, it will over-oxidize lithium polysulfide to inactive sulfate. For example, MnO2, it has a redox potential located into 1.6 to 2.8, so it can catalyst solidified to this group and lithium sulfide. It speed up connected. This is mantle sulfides or COS2. COS2, there also has a similar performance, higher current density, and faster charge transfer from EIS, we can say. It has a good stability, capacity decrease ratio just 0.0034% per cycle at 2 C-rate. And under the catalyst, there is a small gap between charge and discharge voltage. It means reversibility is very good. This is another metal sulfide. Also, we can see there is a high current density and high exchange current and faster charge transfer. This is metal nitride. We can see that there is a large bonding energy between catalyst and lithium polysulfide. All the catalyst is according to the requirement. Polar to polar interreactor or Lewis acid to Lewis base interactor. Yeah. This is metal phosphide. From here we can see also the similar performance, the positive shift and the negative shift. And from here we can see lithium sulfide nucleation energy is higher. This is another kind of metal phosphide. This is a metal-free catalyst, phosphorine. Yeah, phosphorine, from this peak we can see it is very stable. Also, there is 2 peaks. It means the reversibility is high. Also, can enhance conversion of lithium polysulfide to lithium fide. This is LDH catalyst. This is another kind of LDH catalyst. Yeah, we can see similar performance. The current density is increase and positive shift and negative shift, and there is 2 peaks and faster charge transfer, and the nucleation energy is higher. This is a hierarchical structure catalyst. Hierarchical structure catalyst can combine 2 materials advantages. For example, VO2 has a strong interaction with lithium polysulfide, and VN have a good conductivity and also can fix lithium sulfide. So we can see from here, we can see there is a higher nucleation energy. This is another kind of catalyst, similar from performance. So this part I list many catalysts, make a comparison. If you have interest, you can refer to this paper. There is some conclusions. Catalyst should have a high conductivity, and the structure should be helpful to ion transport on its surface, because the migration and coupling of ions and electrons are necessary to realize the fast conversion of the lithium polysulfide. All the material catalysts should have a strong interaction with polysulfide, like some doping atom. So that's all. Thank you.